Yeah, my name is Björn Wendland. I'll be here to tell you a little bit about our migration journey from Java to Kotlin. And I'll start with a small introduction. So I've been working for Metronome now for 3 months, so quite a short time. But then I really learned a lot in this time, and also did a great lot of stuff with the people. For instance, the migration. And for all of you wondering what we are doing at Metronome, so we're a small company that roughly has around 2,000 employees. We're working as a supplier of software for the Metro company. And we're basically building the whole fulfillment process from ordering to delivery, and also the software solutions for other Metro customers. So quite a lot that we do. And I myself am part of the payments vertical, which provides a payment solution to our online shop. And I will tell you a little bit about how we migrated from Java to Kotlin. I won't be teaching you how to write Kotlin code, because there's been a lot of talks about introduction of Kotlin, and Kotlin by now is established for a few years. So I hope that most of you already are able to at least read some Kotlin, though the code examples I will explain. I also don't want to teach you about how to migrate actually from Java to Kotlin, but share our experience with you and also give you some reasoning for that. And since we will be touching the topic of coroutines, which is a way to actually write asynchronous code in Kotlin in a very nice way, I also won't give you best practices for that, but rather tell you how we used it in our project and what we actually did with it. So in summary, what is this talk about? So actually sharing our experience during the migration, stating you the differences between Java and Kotlin, and giving you some of the benefits we see in Kotlin. And maybe this is the key takeaway for you, to actually see why it might make sense for you also to migrate from Java to Kotlin. And then within the talk, and by presenting you all of our experience, to actually give you some insights in how we work and think at Metronome. So cool. Let's start off with a migration story. First of all, I want to give you an introduction into our technology stack. So my vertical, especially, is working with these technologies. So we're managing our project in Gradle. Our programming language by now is Kotlin. As a framework, because we're building a RESTful service, we're using Spring Boot, which is a framework to build a RESTful service. We store our data in a Postgres database, so a relational database. Run everything as a Docker container on Kubernetes. And finally get it deployed using GitLab as the CI/CD tool. So continuous integration, continuous delivery tool, and monitoring everything with Grafana as monitoring tool. This stack actually changed over the course of time. So we started out with a web framework provided by Freiheit. And our intention was to actually move away from this proprietary library and go to something that's more available to everyone. For Kotlin, I will give you reasons in the talk. The rest of the stack you can mostly find in all of the teams at Metronome. Why did we actually migrate from Java to Kotlin? So what was our motivation to do so? So first of all, you have to know about our self-perception within Metronome. So our claim is that we're setting the pace in food and technology. And that's something we actually want to honor. So with that, we see Java, and Java is still the strongest language in the market with 22% of market share. But then we see there's a lot of new technologies, new languages rising, and Java is not always the best for the solution. So we looked into different languages, and for our vertical, for the payments vertical, we thought about Kotlin as a replacement for Java. And we actually wanted to get rid of Java because of some of the controversial design decisions that I will tell you now about. Oh, sorry, I forgot. So the actual trigger to start the migration was Google's announcement that Kotlin is now officially a supported language for Android, which told us, okay, Kotlin is ready to be used in a larger scale productive environment. So that was kind of the get-go for us. How did we migrate? So Kotlin is a language provided by JetBrains, or implemented by JetBrains. JetBrains provides IntelliJ as a coding environment, and you can simply convert Java code to Kotlin code by just copy and pasting it, the Java code into a Kotlin file, into IntelliJ, or the tool they provide online, and have it migrated automatically to Kotlin code. So we started to do this with some selected classes. So for instance, our DAOs, our data objects, we kept in Java, but the clients that would handle the requests, we would migrate to Kotlin using the automated migration tool. So for some time, we actually had Java and Kotlin side by side. And as you might know, both are JVM language, so this is not at all a problem, and it goes really fluently. So after we had migrated the classes, and we did this very confidently because we had test coverage for all our classes, since we work in a test-driven environment, we started to migrate our tests, and we followed the same strategy. So first of all, we would migrate the tests using the automatic conversion, and sometimes we would actually get some code that would not compile, and that we would simply rewrite manually. So for instance, issues when converting actually might occur when you're using optionals, because optionals is something that Kotlin does not have in that way, because the type system of Kotlin is different and handles null values different than Java, which creates issues with automatic conversions. So we had to take this code that might not compile and rewrite it manually. And then as a last step of the migration, we said that we actually want to migrate to Kotlin native libraries, and we did this by introducing them slowly. So the first service we migrated was still running on the Freiheit library, or the Freiheit framework. So we kept the base framework, but for instance, as a testing framework, we used Mockito, which is one of the most used mocking frameworks. And the equivalent for Kotlin is Mock-K. So we started a new test with the Mock-K framework, and we followed the Boy Scout rule to leave code cleaner than we found it for the other classes. So once we would enter another class, an old testing class, we would just substitute Mockito with Mock-K, and therefore slowly fade out the old framework. But actually, moving to native libraries was one of the hardest things to actually do, because there's three major points that you have to consider, especially because Kotlin is such a new language. So first of all, as you already might get from the example how we migrate, there's no actually need to force migration. So we're on the JVM stack, all our Java libraries still work, and there is a saying in software development that you should never change a running system. So there's actually no need to force migration. Second of all, Kotlin is a new language, and therefore the Kotlin frameworks are new frameworks. So oftentimes they are less matured and less documented than existing Java frameworks. So we tried to find the frameworks we needed the most, where we had the most touch points to migrate them, for instance, Mock-K or Mockito, and then just fade them out slowly and find a substitute that's actually well matured or well enough matured and well enough documented so we could actually use it. An example where we did not go with the Kotlin native framework is the web framework itself that we used for our second new service that we would start with Kotlin. So we took two frameworks into consideration. There's the Ktor framework, which is a Kotlin native asynchronous web framework. And then there's Spring Boot, which is an established and reliable Java framework, or Java web framework. So, and Spring Boot provided us the benefits of this established framework, and it's a reliable framework. It had a very good, or it has a very good documentation compared to, especially compared to Ktor. And then it enforces a project structure that we wanted, because we knew that we started out this new service small, but it would grow. So a structure would be very beneficial for us. So we decided to not use the Kotlin native framework and actually go with the established Java framework. So I named this Java or Kotlin. I had this name Java versus Kotlin because I now would like to do a little comparison with you. Which features do the languages provide? Where are they different? And actually, where are the benefits of one language over the other? And why did we actually choose the language Kotlin over Java in the end? So Java has a few controversial features that we think of controversial. These are checked exceptions, SAM types, and wildcard-types. Checked exceptions means that when we have an exception in Java, and you can see the exception being thrown in line 10, and this is a very basic example. And sorry for my my German coming through here. So yes. So if you throw an exception in Java, like you do here, so we basically call the method here, throw the exception, and then we have to handle it. And we either have to catch it or we have to rethrow it, which adds a lot of code just for handling exceptions to Java, even though it might be unnecessary for your use case. And that's something we found that we did not like. So it was, we decided, let's look for a language that does not have this kind of checked exceptions, but rather has unchecked exceptions. So exceptions that you do not need to handle immediately and do not need to declare every time you just want to rethrow it. SAM types, so single abstract method types, are types like callable, comparable, runnable, basically interfaces that only implement one method, and therefore provide what they actually are called like. And this is a very simple example of a callable, which basically is just what lambdas are. And we thought that foreshadows something that we would like to get rid of. And actually this is something in the Java community, some like it, some don't. So this is a general, or this is a feature that you generally might call controversial at all in Java or in programming languages that have it. And we decided, yeah, that's not something we like in our services. We want to have straightforward types. And then wildcard-types, basically allowing you, whether you have an assignment, to not know of which type, in this example, the hash set is of, or in the second example, line 3 and 4, we declare a list that extends number. So we could call it with like any type that extends number. For instance, integer, long, they all extend number. So this declaration in line 4 allows you to basically provide a list of any of those types to this method. And that was something that we experienced in the past to be very complex if we have that. It gets hard to read. You have a lot of casting to do if you have a wildcard type. So we did not like that too. And then we looked at Kotlin, and we found a few features that we said, wow, these features, we want to have them. And if you actually want to have a look at the whole list of features that Kotlin provides that Java does not provide in this way, or issues that Kotlin thinks it addresses over Java, you can just go to the JetBrains documentation and file the whole compiled list, and this is only a small accept from the list. So first of all, we were looking into null-safety. So who of you is a Java developer? Can you raise your hand? Like almost everyone. Cool. So you know that one of the most annoying things is the null pointer exception. So, and Kotlin gets rid of it by having the type system taking care of null. So for instance, in line 2 and 3, you see a declaration of a string that cannot be null. And in line 6 and 7, you have an example where the thing could be null. And if you try to assign null to a type that does not support null, you actually get a compile time error and not a null pointer exception at runtime, which is the really annoying thing about having null pointer exceptions. Not that there is a null pointer exception per se. That's okay. But most of the time you just discover it at runtime, which might be in production. So that's not something we want to have. And actually, once you declare a nullable in Kotlin, every time you access it, you have to handle it as a nullable. So for instance, call dedicated methods on it to assign a new value to it, whether it's not null, or modify the value it holds if it's not null. And since we are a payment vertical, it's really important to us to not have null pointer exceptions in production because, well, we're handling money. And for those of you who've been at the previous discussion panel for a backend language, as the fellow PHP person said, yeah, the money is not gone, but it might be just somewhere else. You have to find it then, so better not have it somewhere else. Then the second feature we really like about Kotlin is extension functions. And basically what an extension function is, it allows you to declare a new member function on an existing type. So in our declaration, we basically declare the new function swap on a list of int. So, and later on, we can just call swap on any list of int to swap two elements. So that was really helpful for us, because you find yourself often that you think, it would really be cool if I had this and that function on a variable of my type. Whether it's a self-declared type, then you can possibly have this as a member function at all. But you also often find yourself wishing like, man, I wish this string had a toJSON method. And you can just add this by providing an extension function, which we found really, really helpful. So toJSON actually is one of the main examples, because we're working with the REST service. So the APIs where we use to communicate with are JSON APIs. So we're switching to JSON all the time, or switching from JSON. So that's one of the main usages of one of the great usages where we use extension functions. The next feature would be data classes. And data classes are just a mean to reduce boilerplate code. By simply adding the data keyword, like here, in front of a class, we give it a defined set of functions. So we do get getter, setter, toString, the hashcode function, copy function, all out of the box without having to write one single line of code, which is really nice to reduce boilerplate code. And I added the second example here, because we can still have the default constructor with just one parameter, which would provide these member functions and additional members of this type. But we need to take into consideration that these do not get the default methods. So if we call toString on the person, it would not return the int or the age as int, because it's not part of the declaration of the main constructor. Then smart cast. So and this is the direct comparison between Java and Kotlin. So Java again has a lot of casting. In Kotlin, it just knows. We just check that if it's of this type, and by checking of this type, Kotlin knows, okay, my object is a string, and I can call all the member functions on string on this object. So again, reducing boilerplate code. And then very important to us was that we can use asynchronous code. So by using Spring Boot, we actually use a synchronous web framework, which brings limitations because it's synchronous. But we have requests we need to handle asynchronously. And therefore, we looked for a language that supports asynchronous code, and if possibly in a very easy manner. And that's where we get into coroutines. So first of all, I want to give you a rough idea where the difference between threads and coroutines is. Because if you think about asynchronous code, you think, okay, I will start a new thread, and then I handle it asynchronously. And this is exactly where you can use coroutines. They have a lot in common with threads, so they handle asynchronous code. But then the scheduling is moved to the programmer. Usually if you have a thread, and I will give you... I will stick to this now. So usually a thread is scheduled by the operating system because you start something new on an operating system level. So it schedules it, and you do not have control when it's scheduled. With coroutines, you as a programmer can say, okay, now is a good time to actually take this code and have it halt or pause and execute some different code, which is a benefit. And then coroutines are very lightweight because they're usually single-threaded. So when you start a coroutine, you just use your existing thread to schedule your code, and therefore allow yourself to do asynchronous programming. Whereas threads actually start a new thread. It has to be managed by the operating system, and therefore it's just more heavyweight than a coroutine. But to be true, coroutines are not limited to be on the same thread. You can also run them in a larger scope on a different thread. So basically, there's nothing in coroutines that basically puts it behind threads. Again, to illustrate this a little bit more, so usually our code is handled synchronously. So we have 3 steps, one after each other. I think this is quite easy to understand. Step 1, step 2, step 3. So once we get to asynchronous code and threads, this example should show 3 threads, and might not be the best graphics, but that's all PowerPoint had to give me in a short time. So we actually have 3 threads now, each responsible for a task that has one part of the main execution. So I have my main thread, the yellow one, which does part 1, spawns a second thread to do a second part that might take a long time, for instance, wait for an input from a different system, and then have a third one, maybe waiting for another system. So we actually create 3 threads, have to manage them on operating system level, and then have to rejoin them later on once we have the results. So this is quite an expensive process. If we look at this in a concurrent setup, not an actual parallel setup, we can do the same thing with coroutines. So we still have our 3 parts of the operation to be done, and we can just say, okay, the first operation we halt after a certain point, then we do the second one, and then we do the third one. So we have the same time frame here to do the same operations. We just do them on the same thread and decide ourselves when to do which part of the operation. And since it's not 3 threads, we do not have to join them. We simply get back to the first one, and this one can now collect the results of part 2 and 3. Cool. So the issue with coroutines is that the JVM doesn't support it, and that's kind of a bad thing, because we want to use them for Kotlin. So how can we get them to work? We actually have to modify the JVM in some of these ways. So there are 4 ways we can do this. So either we actually modify the JVM, we create a patch, and actually provide a different JVM than the default JVM. We can modify the bytecode by, for instance, adding libraries to our JVM that's able to handle coroutines, and that's actually what Kotlin does. So if you're running Kotlin on the JVM, you have additional packages that you supply to your JVM that allows Kotlin code to be executed. Then we can have platform-specific implementations of the Java native interface, which is basically just telling that the operating system or a C implementation handles the JVM for you, and you can have it done by threads. So we use the lightweight, but still have coroutines, which is also nice. So when we are in an asynchronous environment now, so we now know coroutines, which is great. We know how to enable them in the JVM. So even if you say we want to use coroutines with Java, you now know how you could do that. Let's see now how does it look in code to actually use asynchronous code. And there's 3 means. The first one is callbacks. So callbacks means that you call a function and you actually pass executable code to it that should be executed later on. And this just gets less and less readable. That's why this is the method of writing asynchronous code that's getting less and less attention. The second one is reactive code. So it's actually a programming paradigm that orients around the data flow within the application. So you just start the operation, you set an observer on the operation, and once it's done, it will update automatically. How does this look in code? So we actually start our first operation. We map a new function, so this is the second function we execute. We have a subscribe event, so once this one's done, we get the result, pass it into the next function, and then get our result. So in terms of reading, we can now read this top to bottom. We don't get a large callback chain that's very unreadable, or compared to this, harder to read. But still, I think this could be better. If we look at sequential code, which is easy to read, this is not easy. And actually, if we look at Kotlin's coroutines, this one now reads very simple, like iterative code, like sequential code. We still need to launch the coroutine with the launch keyword, but then it's just calling one method after the other. So we start with the fetch user string, we deserialize the user, and we show the user data. Very simple to read. And it's all around keywords like await, to actually wait for the result, and enable scheduling within the functions. Cool. Let's get back to our migration story. So how did we use coroutines within our project, and why were coroutines such a big deal to us? So by now we should know about the benefits of coroutines. So the easy readable code and the lightweight construction. But where would we use them? So we have our synchronous framework. We actually provide an asynchronous endpoint for our service using coroutines. And then we had a different goal. So I already told you that we had the one microservice where we started migration with, which was based on the Freiheit libraries. So this supported synchronous calls. The new service we set up should support asynchronous calls, but still needed to provide one of the synchronous endpoints because we have other systems that rely on our services. But then we wanted to get rid of the old Freiheit library, so therefore we wanted to remove the old service but keep the endpoint. We did not want to have a redundant code base, so just copy it into the new service and have a nice, clean, new asynchronous endpoint and a copied old synchronous endpoint, which functionally does the same, but just has redundant code to maintain. So how did we do this? So we actually emulated a synchronous endpoint using our asynchronous endpoint. So this shows our actually asynchronous endpoint. So we have the Spring Boot annotations allowing the mapping for the capture endpoint, showing the input. So our service consumes JSON. It will output JSON. Since it's asynchronously, it will immediately respond with the accept status, and then we actually start the endpoint. So you can see that very easily we basically just launch a coroutine and then